Hey, so welcome back, and this is another daily LeetCode problem. So today it was actually yet again another cost optimization problem, or dynamic programming problem is a better term for it. So yeah, so basically what you're given is a set of days that you want to travel. And so this is kind of the calendar year, or the day within the calendar. So it's like the first day, which would be like January 1st, January 4th, January 6th, and so on. So this could go all the way up to 365. And then you also have the costs associated with 1-day travel passes, 7-day and 30-day travel passes. And so what you want to do is say, okay, I want to gather what the minimum kind of cost that associated with traveling for every single one of these days. We don't really care about traveling on the day 15 or day 14. We just want to make sure that we use whatever tickets we need to travel at the most affordable cost. So whenever you think of minimization or maximization or anything with optimization, like you should think of dynamic programming, and that's kind of the solution for today's question. And so there's multiple ways you can do kind of dynamic programming. This one's going to be like one-dimensional. Sometimes it's like a two-dimensional array that you need, but for this, since we're just kind of dealing with kind of days in a calendar year and costs, like I kind of naturally thought of, okay, we want to use like a one-dimensional array, but often you can use a 2D array. So always try to think of how can I formulate my DP array to kind of match this question. And so what we're going to do is we'll have our DP array initially set to 0, and this is going to represent, okay, what is the cost, kind of minimal cost that we found so far for traveling on a particular day. And so we're going to multiply this by kind of the last day plus 1. And so that last day will be the last day that we want to travel on, which will be the number 20. And so if this was day 365, the length of this DP array would be 365 plus 1. And we add the plus 1 here because it's not 0 index, it's 1 index. So we want to go from like 1 to 365 and not 0 to 364. Okay, and so to grab the last day, we just look at our days -1. And so next, what we want to do is also we're going to have a set just called like travel days. And this is just used so we can kind of get an O1 lookup of the days that we actually want to travel on, because those are the days that we will actually consider the cost for. And so that will be just, the set of the days that we want to travel. And so now what we're going to do is we're going to iterate through every day between 1 to the last day that we want to travel. And so from there, what we expect is that we'll return the last index within our DP array. And this is kind of just common templated dynamic programming problem like solutions, is that typically you would build your array so that as you're solving the problem, you're kind of aggregating that minimal cost all the way until you reach the last day, which is, this is what it would cost to travel every single day of the year that we want to travel on. And that will be kind of held in the DP array here at index 20. And so from there, what we're going to say is, okay, if this day is not in the list of days that we want to travel, we're just going to ignore it and just aggregate that minimal cost forward, because we don't really want to say, okay, we don't want to add any extra cost to travel on day 15 for this example, because we don't really care. Like, we just care about travel on day 20. And so that's just going to be, okay, the DP at this day will be equal to the day previous of it. Otherwise, we do actually want to consider the cost. And so it'll be the result of kind of our minimization function, where we consider these 3 scenarios. And so the first scenario is we'll look at the previous day from the current one, and then we basically just add the cost for 1 day. So this represents kind of a 1-day pass. And so you just say, okay, get the minimal cost for the previous day that we've been aggregating forward, and just add, okay, if we go from that day plus this running cost of 0, what would it be? Great. And so from there, what we'll do is it cost? Cost with an S. Is we want to do the same thing, but we'll want to look at 7 days ago. And then we'll say, okay, what is the cost of that? And we add the cost for a 7-day pass. And then same thing with a 30-day pass. Now the only issue is then this one won't ever throw an exception because you're starting at index 1 and index 0 will hold like 0. And so that solves the first case. But if we're at index 1 and then we do a -7, this will go out of bounds in our DP array because it'll be like -6 index into our DP. So we'll actually just want to do, okay, take the maximum. And this is just a little Python trick where you just take the maximum of 0 in this. So if it is negative, you just grab index 0 instead of like index 6. Great. So let's just try that. Oh, and we want brackets here. Oh, I think there's an issue. Oh, we want 2 here. Oops. Yeah. Okay, great. Yeah, so that's it. Basically the time complexity for this is in the space complexity. So for space, this DP array will be at most 365. So that's kind of like a constant space. It won't grow linearly. But this travel days is extra space that we're using out for that kind of O1 lookup. So it's kind of a time and space trade-off here, is so that by saving on space or saving on time, we require some extra space and storage here. And so that will be kind of O of n, where n is the number of days here. And then for the time complexity, we're just going to be iterating through every day in this list. So that's also O of n, or every day between, I think it's kind of constant time because you just iterate through each of these options and then you go at most the last day. Yeah, so it's kind of bounded on 365, so you can kind of say that it's constant time and space, really. But to be safe, I would say that it's O of n time and O of n, it's definitely O of n space because you're grabbing all this here. Yeah, okay, so it's O of n and O of n in my book, but feel free to add in the comments what you think it is and any solution that you provided and how you did it. Maybe you did this is a bottom down approach with a one-dimensional array. Maybe you did a top-down approach with memoization and a 2D array, but feel free to post your code in the solution and let me know what you did and what you think the time complexity is. So yeah, I hope that helped, and good luck with the rest of your algorithms. Have a great day.